Welcome back, everybody. Before it's too late, I'm going to just continue and knock out the T's. We've got, we skip transduce, we've got transpose. I'm going to skip traverse as well because of all this Fantasyland specification stuff. Trim and tryCatch and type. That's what we'll look at in this video. So let's start with transpose. So transpose takes a list of A's. Actually, it takes a list of A's and returns another list of A's. So the name transpose tells you a lot. Let's go and expand these parameters. So they call this a 2D list. That's probably an easy way to refer to it. So it takes a 2D list and it returns another 2D list. Um, so what it does is it transposes the rows and columns of a 2D list. When passed a list of n lists of length x, it returns a list of x lists of length n. So let's look at that. It's pretty straightforward, uh, but it's easier to see than it is to say. Okay, so here's our outer array, and inside we have three pairs, where the first item is an integer and the second item in each pair is a string. And so when we log this, let's put it up here so we can see it. Oh, I was hoping that it would format it the same way. Why? There we go. Um, so see what it did here? It's easier to look at it and compare than try to describe it with words. Here we have a list of two things with one an A. So basically took the first thing from each list and put that in its own list, and the second thing in these pairs and created it on its own list. So we still have a 2D list, but here we have three things with three pairs, and here we have two triples. So that's the difference. So again, this is one of those functions that help you format data structures, or reformat a data structure. Better yet, to say change one data structure into another one, but it's still preserving the same relationship, so to speak, just in a different structure, right? So let's look at this other one. So what are we doing here? We're just going to get rid of that. This is what we just created. And so here we're just going to flip it back. So now we're back to the 1A, to the pairs of a list of pairs. Yeah. And then this note here, if some of the rows are shorter than the following rows, their elements are skipped. So let's look at this example. Okay. So in this outer list with the blue square braces, that's the outer list. Then we've got a pair, we've got a single, we've got an empty list, and then we've got a triple. And it says if some of the rows are shorter than the following rows, their elements are skipped. And when they say there, I think they mean if some of the rows part, like the first thing. So let's just run it, see what we get. All right, so to transpose it, we're taking the first thing in each list, 10, 20, empty, and 30, and putting in that in the first new list that we get. But because this is shorter, we're skipping it. Like each one of these has a first item, 10, 20, except for this one, and 30. And in the second list, taking the second item, 11, but then we skip this because this is the second item, and this list doesn't have a second item, nor does this have any items, and then 31. And then we're out of elements here. We're out of elements here. We're out of elements here. So we go to this one and we get 32. And that's what you get. So that's transpose. Um, yeah, I would use this if I remember it existed at the time that I needed it. And there is this cool command line tool for Ramda. It's called Ramda Suggest, I believe. And you can show it input or output that you want given an input, and it will suggest to you Ramda functions. I haven't used it, but I know it's there, and I probably will at some point. Excuse me. However, you can just use AI too. Ask ChatGTP; it'll probably give you a good answer. Um, so we're going to skip traverse, and we're going to look at trim, tryCatch, and type. The trim is one of these that is built into the string prototype. Um, so it's a method on the string prototype in built in JavaScript. It takes a string and gives you another string, and it just strips the white space from both ends. So this will be a quick one. So we trim hello, right? And we log that. Oh, and we get the string with no spaces. And then if you did something like this, it still works. It leaves this space because we're just trimming the empty space from the beginning of the string and the end of the string, but this is in the middle of the string and it's intentional. And that's what trim does. And there ain't nothing else about it. Let's see how they implemented it. Wow. They're doing a lot of things using regular expressions and replace method. Here they're just calling string.trim. So I'm trying to figure out what all this is. So it does not have if the prototype does not have trims, that must be their own function. Yeah, it has oh well they just implement it here. It looks like the type of trim is a function. And then WS trim, I don't know what WS is. Oh, look at that. That's so weird. All these characters, like Unicode stuff or something. Maybe that's like stuff you don't want to trim. Yeah, I don't know. It looks pretty complicated given the description. They don't give you any like dispatches to something or other if it's in the something position or I don't know. That's trim. Let's move on to try catch. And this one's pretty useful. You know, we have try catch statements, right? But in functional programming, we don't usually use statements. We try to use expressions. And the way we handle expressions frequently is to use a function that takes arguments and uses those arguments in the expression. So functional programming is really more expression-based programming. Functions are just the tool that we use for expressions. Um, but things can fail and they get their errors, and we want to be able to compose. And how do we handle errors in function composition? And the way we normally would do it is we use these special types like maybe, result, either. These are things like maybe, for example, is designed to use when you may have a value, but you may have undefined or null. And then like result would be like something that may succeed or throw an error, like a fetch request. Like there might be the API might be down, or the endpoint might be down, or whatever. So you can get an error, and you want to be able to handle that. And try catch is not a statement; it's a function, and functions can be composed. So that means we could use try catch inside like a pipe or something. So let's look at it formally. So we've got this function dot 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 x, and I haven't seen that before, but it's a function of something x returns an a. Then it takes a function that takes e, so that's probably error, or x, and that probably has something to do with like the happy path, and that returns an a. And then it gives us back a function. It takes an x and returns an a. So the only mystery here is, what is this dot 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 x? Okay, so this is the trier function that may throw. This is the function you're trying, that we're going to wrap with try catch. And then this is the catcher, the function that will be evaluated if trier throws. And that's why we have an e here. But we also have the x, and it returns an a. Either way, we're going to return an a. And presumably, we're not even going to run this function unless there's an error. We're just going to run this function. And then it gives us a function that we use. Returns a new function that will catch exceptions and send them to the catcher. Okay, so tryCatch takes two functions, a trier and a catcher. The return function evaluates the trier. If it does not throw, it simply returns the result. So that's the happy path. If the trier does throw, the return function evaluates the catcher function and returns its result. Note that the effective composition with this function, both the trier and catcher functions must return the same type of results. Interesting. Same type of results. Okay, so let's start with, I've got my own, but let's start with their example. Work our way through it. Okay, so we're going to try to get the value of the property x in an object. That's our trier, and this is our catcher, and it's the false function, which always returns false. So if we have a value of x on the object that we pass in, we're going to get that back. And if we don't, we're going to get false back. And if we didn't do this, we would get like undefined or null or something. Or no, we just, I guess they're saying it would throw an error. And I thought that we would just get undefined. But maybe that's a side question. Let's run this. And we're passing in an object or data with an X that's the value is true. So we should get back true. And we do. But if this was a Z, we get back undefined. Interesting. So this doesn't even throw an error. And maybe that's what they're trying to demonstrate here. You use a try catch and it doesn't return an error, you're not going to get the catcher. It's just going to return the value of x, which is undefined. I'm pretty sure that's what they meant here. They might have maybe could have like specified that in the output. All right. So let's do this one though. So again, we're passing in two functions and then our data. So this one, our first function, it's a little hard to make out. It's that right there. That's interesting. We're actually our successful function, our trier function is just going to throw an error. Like that's what we're trying to do. Um, and therefore our catcher should catch it and return the string caught because we're using this constant function always. And then we pass it bar, like it doesn't even matter because we're throwing an error, and so we're going to catch it. And it says caught. So I mean, this could be nothing. We're still going to get caught. Okay, so I see where they're going with these examples. They're like slowly walking us through. So if we do r dot tryCatch here, there we go. So we can see clearly. So we're going to do the identity S amount of times. That doesn't make sense, right? Because times takes callback function and a number, and here we're passing it a string. You can't do something S times. So that is going to throw an error, I believe, and we're going to get back. So it's going to run this function, and so we're going to default to an empty array. Let's save that and run it, and we get an array back, empty array. But if we change this to 32, then it's just going to pass the identity of 0, or the identity 32 times, starting with 0 and incrementing one time for each number that you pass into it. These are good examples. I rate these. Let's check this one out. All right. So here again, we're explicitly throwing an error. This is not a valid value. Our catcher is going to accept an error and a value, which you get back from an error object. And then we're just going to pass back a formatted object where we show the error and the value. And then we pass it bar, but again, it doesn't matter. We're just invoking it. We get error. This is not a valid value, and the value is bar. And even if we pass nothing, we should get the same thing, but the value is undefined. Again, the value is undefined. So these are cool, except I think they should like throw in something that might be slightly useful. So let me take a crack at that. Let me make a pipe and multiply by 2 and increment by 1, or just increment rather. And Let's tap at the end of it and log it so we can see something on the screen. So we get, oh, and pass it a value. So pass it 32. We get 65 because we get double at 64, increment it, that's 65, and we log it. Now how could we do an error? What if we uppercase do to upper the string? Will that cause an error? Yeah, that causes an error, which is 64 does not have a method name to uppercase, right? So what we could do is we could wrap this whole thing in a tryCatch because tryCatch takes a trier function and a catcher function. And this whole pipe is our trier function. So open the parentheses there, close it here. That's our first function, our trier function. And then our catcher function could just return always like 100, right? So let's say in this use case, like the default value is 100, like, for whatever reason. And we will format that. Actually, it's better the other way. Manually format it, right? So our trier function and our catcher function. Let's see if this is right. I know it's not for one reason, but let's see if there are other reasons too. First of all, put that there. All right, so yeah, we got an error and it says 64 does not have a method name. It's a type error. Okay, I'm not exactly sure, but I do know I know one way to fix it. Okay, so we're back to here. Let's just make sure this works without two upper. We get 65. Okay, but if we include it, we got that. So this is a little bit contrived now. Oh, the whole thing's contrived. Now it's even more contrived. But I'm going to wrap this in a try catch. Oh, hold on a second. I think I know why this didn't work. This. This needs to be passed here. Let's see if this works first. If not, I'll go to my other example. Yeah, it does. But the problem is, so I need to pipe this as well so that I can put a tap r.tap log here. Right. Okay. And so we get 100. Right. But if I get rid of to upper, oh wait, I can't do that. That's what I'm trying to. Yeah, if I get rid of to upper, then I get 65. Let me go and format this a little better. Um, so I consider this as like this is a pretty easy way to handle errors. The downside is you're handling all possible errors that can be thrown by any function in the pipe. And realistically, you probably want to have more control over what kind of errors, like depending on which function causes the error. But at least this is like better than just not doing anything, like not handling errors at all. Right, so that's our, yeah. So we pass 32 to the try catch statement. The trier is a pipe that tries to multiply it, increment it, and then I did the multiply to uppercase, and then increment it, and then log that. But of course, it's going to fail because of the thing. And of course, you could wrap every function in its own try catch, and that would be a whole nother level better, um, because you could have controlling your error message or your catcher function for each thing. But again, we'll find that it's better to use something like a maybe or a result or an either type. And when I say better, that's in the eye of the beholder. But